Hello everyone, welcome to Scholar Lab. Our simulations can transform your teaching approach, making lessons much more interactive and captivating for your students. Scholar Lab is a distinctive virtual laboratory that brings intricate STEM concepts to life through engaging simulations. This tool is crafted to aid students in comprehending and applying scientific principles in practical situations. Let me take you through an electrifying journey into the world of combustion. Today, we are going to explore what makes fire burn, how we can control it, and the mesmerizing structure of flames. This isn't about the learning facts. It's about understanding the magic behind fire, the force that has shaped civilizations and continues to power our world. Get ready because we are about to dive deep into the heart of the fire triangle and uncover the secrets of flames. Let me open combustion simulation for you. Each simulation begins with a game plan that outlines the procedures, observations, and learnings of the simulation. If you are a new user, kindly go through this section thoroughly to maximize your experience. Our main objective of this simulation is to explore and understand the behavior and characteristic of fire and flame. Here we have three parts in this simulation: fire, flame, and quiz. Before getting into the concept, I would like to show you the different angle of view of our chemistry lab. By using your mouse cursor, by click, hold and drag, you can view that in many different angles. Also, you can click on this bottom right button to view that on 4 different angles: T for top, F for front, R for right, and L for left. Let's get started with the concept. First, let me take you through fire. Here we have many materials to be tested whether that is combustible or non-combustible. Before getting into that, you can see a triangle over there in the right hand side of your screen. That is fire triangle. These three simple words that hold the key to every fire you have ever seen: fuel, oxygen, and heat. Each side represents one of these essential ingredients, and together they create a spark of life for any fire. Fuel is a stuff that burns, whether it is wood, gasoline, or even a candle. Oxygen, that is invisible gas in the air, feeds the fire. And heat is the energy that gets the whole thing started. Now we are going to check how this triangle works for these combustible and non-combustible materials. For that, I'm clicking on the Bunsen burner to get it started. Let me check it with CNG. It is combustible material because all three in the triangle works fine. What about LPG? Again, that is combustible. What about kerosene? As you can see, we are checking those materials and automatically that is updated on the board whether that is combustible or non-combustible. Let's take it with petrol. What about wax? Matchsticks? As you can see, once the sticks are burned completely, fuel and heat becomes red, which shows that is not combustible anymore. But basically that is a combustible material. Similar thing works for straw also. What about stones? It's not combustible because fuel is missing over here. Wood, coal, paper, iron nails, as you can see, the glass is not non-combustible material. All those materials and the combustibility which is given on the board thoroughly. You can zoom in and view them clearly. Let me take you through the second part under fuel, that is oxygen. Oxygen is the breath of life for fire. Here we have three kinds of glass jar and a candle. The first one, which is having open on both the sides. So the candle is burning now. And what about I'm having this glass jar that is having open on single side. Still the candle is burning. What about the glass jar that is having any open on both the sides? After some time, once the oxygen level is lower, the candle is not burning, which clearly mentions that oxygen is very important for fire. As the third part, we have heat. For this, we have two cups. One is having water in it and another one is empty cup. Let me place both the cups on the Bunsen burner. As you can see, the fuel is set up and I'm turning on the burner, and let me check the temperature of the water also. As you can see, the paper cups are burnt, so the fuel and heat is not anymore. What about the paper cup with water? Once the water gets evaporated, paper cup will turn to be ashes. Now the fire will not come. Let's put our knowledge into the real life situation. Here we have two kinds of setup: building on fire and electric fire. Now you can ask your students to control the fire on both the setup. What kind of fire extinguishers can be used to remove the fire or control the fire on the building? By using CO2 or by using water? Let's try it out by using CO2. Let's see how it happens. By using the mouse cursor, by click, hold and drag, you can try to control the fire, but it will not work better for this case, because in this case the volume and the ability to reach the inner part of the house is not good for CO2, and also CO2 extinguishers can't be used effectively from safe distance. What about electric fire? For electric fire, water would be disastrous. Instead, we can use CO2 or dry chemical extinguisher which cuts off the oxygen without risking the electrical shocks. What if I'm using water over here? As you can see, the electrical shock created, so the factors affected are oxygen supply and heat. So water can be a good fire extinguisher for controlling the fire which is electrical. Let's dive into the second part, that is flame. Under this we have appearance of substances. Have you ever wondered why the flames on the gas stove are blue while coal burns with a deep orange glow? And an LPG burner shows a steady blue flame. It's not just about the fuel, but the elements involved and how they burn, which is clearly shown here. As we look at the different flames, we'll see that each color tells a story about what is burning and how efficiently it is doing so. It is a fascinating way to see chemistry in action right in front of our eyes. By turning off the lights on this room, you can clearly view the different colors of flame produced by the Bunsen burner, candle, LPG stove, coal, and etc. Let's test it. The different layers of candle flame by this experiment. Here I am having two test tubes filled with water. One is 20 degrees Celsius, another one is also 20 degrees. But the position of the candle is different. Let me start the candle by using the sprint. Let's focus on the humble candle flame, something we have seen 1,000 times. But have you ever looked closely at its layers? At the base, there are a hot blue zone where the complete combustion happens. Move up a bit and there is a bright yellow orange zone where the flame goes and flickers. As you can see, after 5 minutes, the first candle produced the water level which is 70 degrees Celsius and the second candle that is 60 degrees Celsius, which clearly shows the different layers are having different combustion levels and which is clearly depicted on the board. The outer zone which is having complete combustion, middle zone partial combustion, and the innermost zone are unburned wax vapors are there. And the top layer which is the hottest part of the candle. That's why the temperature got increased to 70 degrees Celsius for the first candle. As the last part of the simulation, we have quiz. Quiz will give you the analysis of how much students have understood the concept. Here we have set of 5 questions to be answered and all 5 questions to be attempted before clicking on the submit button. Once you attempted all 5 questions, click on submit to view your score, and also you can click on this check answer button to know what are the answers right and what are wrong. And also you can click on explanation button to view the explanation of the question where needed. We have journeyed through the heart of the fire, explored its very essence, and peeled back the layers of flames. From understanding the fire triangle to uncovering the secrets of a candle's flicker, you are now equipped with the knowledge to ignite curiosity in your students. Thanks for watching.